Hello Honors Pre-Calculus students, this is Mr. Gazzato, and today's learning target is to completely factor the following polynomial functions and find all real zeros without the graphing calculator. You should have learned most of these techniques last year. If there is a technique you're not familiar with, you can try the evens problem. I will do the odds, and if you need more practice, you can ask your teacher. So if you look at problem number 1, the first thing you should notice is you can factor out the x, so then you get x squared minus 1, and then it's x minus 1, x plus 1, so there's the completely factored form, and then the zeros are x equals 0, x equal 1, and x equal negative 1. In calculus, there is a non-calculator portion of the AP test, so you should be able to look at that function f of x and then be able to visualize the graph using the intercepts and end behavior. If you want a practice problem, try number 2. In problem number 3 here, the same idea. You can factor out the x. So then you get x squared minus 2x minus 41. That quadratic is not factorable over the integers. So at this point, you're going to need to use the quadratic formula. So x is equal to the opposite of b plus or minus the square root of the discriminant, all over 2a, so 2 times 1. Calculating the discriminant, so b squared, so I'll write this down for this time, so b squared minus 4ac. So then x is equal to 2 plus or minus so b squared minus 4ac, I forgot the 1 there, let me add that back in. So 4 plus 4 times 41, you get the square root of 168, all over 2. You could break down the 168, I believe 4 is going to divide that. So 2 plus or minus 2 square root of 42 over 2. And then when you simplify this, you get 1 plus or minus square root of 42. So remember, there are really 2 answers here, 1 plus root 42 and 1 minus root 42. So to completely factor this, f of x is equal to x minus the quantity 1 plus root 42, and x minus the quantity 1 minus root 42. And some people will distribute that negative. I'm perfectly fine if you leave it in that form, but if you look at the answer key on different textbooks, you may see the following. You should know that those are equivalent. So there's the completely factored form. The zeros are 0, 1 plus root 42, and 1 minus root 42. If you want a practice problem, you can try number 4. Okay, problem number 5, same idea. We're going to factor out the x. And something happened with my video. Same thing with problem number 5. We're going to factor out the x. So that'll be x squared plus 6x plus 18. And there in the quadratic formula, where does that factor? See, 18. Factors of 18 that add to 6. I don't think there are any. So I'm going to use the quadratic formula again. X is equal to opposite b plus or minus the square root of the discriminant over 2a. So b squared minus 4ac. You're going to get negative 36. So then x is equal to negative 6 plus or minus 6i over 2, which then is negative 3 plus or minus 3i. So the zeros for this function are 0, negative 3 plus 3i, and negative 3 minus 3i. In completely factored form, x times x minus the quantity, negative 3 plus 3i, and x minus the quantity, negative 3 minus 3i. Again, some textbooks and some authors will distribute, so x plus 3 minus 3i, x plus 3 plus 3i is completely factored. Okay. Problem number 7. The idea here is to review factor by grouping. So you should recall from last year, if there are 4 terms, one technique is to factor by grouping. So the first 2 terms have an x squared, so x minus 3. You could factor out the 4, x minus 3. Notice the x minus 3's are in common. So the next step is to factor out that x minus 3. And then you get x squared minus 4. Some people will just write x squared minus 4 times x minus 3. You should know those are the same. So that x squared minus 4 factors further. So x minus 2, x plus 2, x minus 3. So there's the completely factored form. The zeros are 2, negative 2, and 3. Problem number 9. Again, factor by grouping. So you could look at those 4 terms and factor by grouping. So f of x, factor out the x squared, so x minus 4. Factor out the 5, x minus 4. Then x squared minus 5, x minus 4. And at this point, I'm going to write the 0, so x is equal to plus or minus the square root of 5, and x is equal to 4. I got that by solving x squared minus 5 is equal to 0. Don't forget the plus or minus. So the completely factored form is going to be x minus root 5, x plus root 5, and x minus 4. Number 11. If you take a look at number 11, I believe we still can factor by grouping. So f of x, factor out the x squared. So x plus 2. And you can factor out the 4. X plus 2. So x squared plus 4, x plus 2. So x squared plus 4 is equal to 0. Solving that, I get x squared is negative 4. So x is plus or minus 2i. The other 0 is negative 2. And then the completely factored form is going to be x minus 2i, x plus 2i, and x plus 2. Okay, problem number 13 looks like it's a quadratic, and if you look at this whole page, they're very similar to quadratics. Some people last year had a hard time recognizing them. So when I look at number 13, I see a squared minus 4a plus 3. And looking at that red equation, I see that that's a minus 3, a minus 1. So looking at the original problem here, instead of an x squared, or an a squared in this case, we have x to the 4th. The a is acting like x squared. So when I look at this problem, I see the red problem, and this factors into x squared minus 3, x squared minus 1. So then x squared minus 3 is 0. X squared minus 1 is equal to 0. So x is plus or minus root 3. X is plus or minus 1. At this point, you can factor completely. So f of x is x minus root 3, x plus root 3, x minus 1, x plus 1. As I said, for practice, you can try number 14. Number 15, Again, when I look at this, I see a squared plus 3a minus 4. So that factors into a plus 3, let me fix that. That factors into a plus 4 and a minus 1. So when I look at that original function, number 15, f of x equals x squared plus 4, x squared minus 1. So x squared plus 4 is 0, x squared minus 1 is 0, x squared is negative 4, x equals plus or minus 2i, and the other one, x equals plus or minus 1. So for completely factored form, f of x is x minus 2i, x plus 2i, x minus 1, and x plus 1. So the goal of this set of problems was seeing that these are quadratic in nature. Okay, number 17, 18, 19, and 20 are sum and difference of cubes. So if you forgot the cubic formulas, a cubed plus b cubed, you take the cube root of the first term, a, cube root of the second term, b. If this symbol is plus, this symbol is plus. Those are always the same. Then you square the a, so you square that, so a squared. You multiply these two terms, ab. If that yellow symbol is plus, this is a minus. These two symbols are always opposites. The last symbol is always positive. And to get the last term, you're going to take that b and square it. So that's the formula for the sum of cubes. The difference of cubes is going to be a minus b. Notice these symbols are the same. So you take the cube root of each. Then you're going to square the first term, so a squared, plus, so these two symbols, the minus and pluses, are always opposite. You multiply those two terms, so you're going to get ab. The last term is always positive, and you're going to square the b term, so b squared. Let's take a look at number 17. So using the sum and difference formulas to the right, the cube root of 27, x cubed, is 3x. It's going to be plus, because it says a plus. Cube root of 125 is 5. Square the 3x, 9x squared, minus 15x, plus 25. At this point, I need to use the quadratic formula. So x is equal to 15 plus or minus the square root of, go ahead and calculate that, over 2 times 9. The discriminant is negative 675. So that's 15 plus or minus. I know 25 divides that. So 5i square root of 27 over 18. I could break that down even further because 27 is 9 times 3. So plus or minus 15 square root of 3 times I over 18. So 5 over 6 plus or minus 5 over 6 square root of 3 times I. The other 0 is x equals negative 5/3. So here are the zeros then highlighted in yellow. I also wanted to completely factor this form, or this function. So f of x is going to be equal to 3x plus 5 times x minus the quantity 5 over 6 plus 5 over 6 root 3i times x minus the quantity 5 over 6 minus 5 over 6 root 3i. Now when you look at this factored form, you got a 3, a 1, and a 1. But the leading coefficient was 27. So right now the leading coefficient in what I have is only a 3. I need to get to 27. So I'm going to need to put a 9 out in front in order for this function to be accurate. You can practice any of these problems here. They're all sum and difference of cubes. Number 21 and 22 are quartics. It goes back to the earlier that you can factor out the x, and then you get x cubed plus 64. At this point you should recognize, oh, this is a sum and difference of cubes, so now it's the same as the earlier problem. So you can practice these. So the learning target today was to factor completely without the graphing calculator. If anything is unfamiliar to you, please ask your teacher and we can create more practice for you.